Thank you so much, Alex. What I really appreciated about your talk, as someone who's been on both sides of the equation as a founder and now as a VC, I really like that chart a lot. I saw some people take pictures of it. I think that's a great encapsulation of sort of the differences, the pros and cons, the evaluation. And what's really interesting and stood out to me is the focus on alignment. And that's actually a big part of, even though we're going to hear from our next speaker, a deep dive into microelectronics, I'll have to say it is extra special for me as one of the team members at Squadra Ventures who actually invested in the next company that you're going to hear from, because it is so much about those pieces behind the scenes. Just as microelectronics power everything that we do, everything that's in your hand, every camera we have, there's also many people that must be aligned to power companies and founders. With that, I'd love to welcome Edgar Garay, founder and CEO of Falcomm, to the stage. A lot of personality with this one. Keep the claps going.
Awesome. And one more. Hold on. Yes.
Thanks, friends.
Awesome. Well, super excited to be here. This is super cool to be sharing all the technology and our journeys as entrepreneurs. So my name is Edgar Garay. I'm the founder and CEO of Falcomm. So we're a fabless semiconductor company. I'm going to tell you a little bit of my story, and I'm also going to talk about the cool technologies that we're developing, why we're developing it, and the impact that it's going to have in the world. So a little bit of my background. I was born in Venezuela, grew up in Colombia, and then moved to the States in 2001. I have a PhD from Georgia Tech. I think I'm the only non-founder that is not from Johns Hopkins. Falcomm was incubated by Berkeley Skydeck, and I've been doing Falcomm for 4 years, and we've built an amazing team, amazing technology. We've raised close to $11 million in VC funds, and we're building dual-use technology, dual-use microchip technology for wireless communication, defense, and EW. So the main thing that we're focusing right now is on power amplifiers. Whether you guys know it or are aware of this, you probably use hundreds, if not thousands, of power amplifiers a month or a day. Power amplifiers are critical for wireless communication. They're the microchip that goes behind the antenna and injects enough power so it reaches the intended target. Historically, these power amplifiers are super energy inefficient, so they're very power hungry. And this creates a lot of thermal challenges and energy budgets. And it's really hard to create new systems, new satellite communication systems, radars, and anything that transmit energy over the air. So that's one of the critical components that we're redefining, and we did this by creating a new architecture that's more energy efficient and that it performs extremely better than commercial components. So this is an example of what happens when you increase the energy efficiency of a wireless transmitter system. When you go from 30 to 50%, it seems like a small incremental increase in efficiency, but what happens is that you reduce the power consumption by 40%, and you also decrease the heat that you're generating by 2.5x, right? So this is incredibly useful for people that are building next-generation satellite systems, next-generation communication systems, EW and radar systems as well. That graph that you see there, it's the comparison of the energy efficiency performance of the architecture that we're commercializing as compared to what you could buy off the shelf today. So it's a huge increase in the energy efficiency. So how does this translate to better systems for national security and mission-critical systems? Well, if you talk about, let's say, tactical communication radios, one of the main issues, I spent a little bit of time working at the Army Research Lab, and one of the main issues that we were trying to figure out was how to reduce the battery load that the soldiers carry. Sometimes they carry up to 40, 50 pounds of batteries, so creating more energy efficient system means that they can reduce the amount of batteries that they can carry around the battlefield. Not only that, but you can increase the performance of radar systems, increase the accuracy. So in a way, increasing the efficiency of the power amplifier can give you a better tactical advantage, right? And we see these across, again, radar, EW, and communication systems. So a little bit of my journey and my personal journey. I finished my PhD in 2021. I actually ended up graduating in 2023, but I spent around 10 years as a grad student, kind of trying to look for an idea that could translate into building a company. I've been studying startup for the past 20 years of my life. I was a solo founder, and I was really interested in building technologies, building teams, and creating a difference in the world through technology, right? So the first 2 years as a solo founder, I don't know if for those of you that are earlier in your journey, it was, as a solo founder was a little difficult, but I've seen that that's how building startups work, right? You have ups and downs, but one of the main things that I've learned is that momentum and keep on keeping on, as I like to say, it's kind of one of the key things that you have to work on as you build your startup. So we're based in Atlanta. We're a team of around 15 people. As I've mentioned before, we've raised close to $11 million, and now we're doing a Series A and working on really cool commercial projects and developing other cool pieces of technologies. This is an example of the products that right now we're commercializing, and this is an example how we went from university lab, research level microchips to high volume production, right? And to do that, we created a lot of partnerships with foundries, specifically global foundries. We also built relationships with assembly houses, packaging houses, and we did a lot of third-party validation. So it wasn't an effort that only was Falcomm alone, but creating a lot of useful partnerships. It's key in developing advanced technologies. The picture that you see there, it's an evaluation board that currently we're sampling to customers, and it's a product level microchip. So just to think about, I don't think that a small team of 10, 15 people could do this 20 years ago. So I think the industry has changed in a way that now small teams that are agile and fast can create high-performing semiconductor products that can outperform whatever is commercially available. So another thing that now we're working on is on the design flow and the software tools that you use to develop semiconductor products. So one of the things that we realized through our journey is that it takes a long time to develop semiconductor products, specifically power amplifiers. It can take up to 2 years to develop, meaning that you have to do a lot of 3D electromagnetic simulations, you have to do a lot of nonlinear transistor simulations, you have to put all that together, and sometimes when you manufacture and you get it back to your lab and measure it, the hardware to simulation correlation is not there. So you have to do it all over again and all over again until you get the right technical performance, right? And the main thing about that is that when we create all those data in terms of simulations and performance simulations, and after the product is done, we throw it away. We don't learn anything about it. The designer and the engineer builds a better design perspective, but as a company, that's kind of thrown away, right? The designer leaves, the expertise lives with the designer, right? So one of the things that we're trying to figure out and we're currently working on is how can we build foundation models and use AI to build products that pass all the manufacturability rules, but where instead of 2 years, it can take us, a month or less than that. So I want to show you this because we haven't shown this publicly, but this is the first PI that we designed using our AI tool that we're calling Gandalf AI. The main element that we use in our PAs is gallium nitride, so therefore Gandalf AI. So the red curve, it's 4 months of development using a team of 3 people. Blue line is 10 minutes of development. And I just want to tell you that, the blue line, it's complying with all manufacturability rules, meaning that it's a product that is ready to sell. And I want to just kind of pause here for a few seconds because we do believe that this tool and these efforts are going to change the semiconductor industry on the RF domain. On the digital side, people have been able to do this 10 years ago, but when it comes to RF, because of the nonlinear behavior of the transistor, the electromagnetic performance of the metal layers and the metal stack, it has been impossible. But we figure out a way where now we can build a product catalog of hundreds of products with a small team in a few months. And that's our goal now, right? So super high performing power amplifiers that be commercially available amplifiers, but also doing them quick and building the product catalog really quick. So these are our main focus areas. So we're building PA products, we're building electronic design automation tools, and also we want to bring manufacturing and testing here. We want to vertically integrate. 80% of packaging of microchips is done outside the US. Why? There is not a reason that we couldn't bring that here. And that's kind of one of our goals. This is the amazing team that is, because all of this is happening. One of the things that I learned is that building amazing teams, it's one of the key components in creating great technologies and creating great technologies. These are some of the lessons learned. The main thing that I'm going to say is that, I hear no probably 2-3 times a day. So in the past 4 years, I probably heard no thousands of, times. So get used to it. Love the word no. And if you do that, I think you can do whatever you want. So follow us. We're hiring. Follow our journey. We're building really exciting technology, and I think next year is going to be amazing for us. Thank you guys for your time.
Thank you so much, Edgar.